Here's a solution to one of the problems from the section on improper integration. And here we see one where the infinity, the unbounded part of the interval, is on the left side instead of the right side, meaning the lower number is the one that goes off forever instead of the upper number. And so if you take a deep breath, it's actually very much the same thing. When we solve one of these problems, the two steps are to first figure out what's happening in this problem as an integral from some parameter n to -1. So this is the other way around from what we've been doing. We've been going from something like 1 to out to n. But this is still just a definite integral. We'll still just use the fundamental theorem of calculus. And our answer when we get this will be in terms of n. And then we will, in the second step, take a limit as n goes to the appropriate unbounded direction, either positive infinity or negative infinity. Now, to do this integral, we see we have a radical and it's in the denominator. So I have to first know that the cube root of x is equivalent to x to the 1/3 power, and then also recognize that x to the 1/3 power in the denominator is the same as x to the minus 1/3 power in the numerator. So this is the same integrand as in the original question, x to the minus 1/3. So now we're in business. The fundamental theorem of calculus says that I should bump up that power by 1. So adding 1 to -1/3 gives me 2/3. And then there should be a factor in front that's just the reciprocal of that new power. So here is an antiderivative of x to the minus 1/3, and this is to be evaluated between n and -1. So that's 3/2 minus 1 to the 2/3 minus 3/2 times n to the 2/3. And minus 1 to the 2/3 is just 1. And so we have 3/2 minus 3/2 times n to the 2/3 power. So the second step is to think about what's happening to this answer. So exactly the expression I got here. What's happening to this as n goes to negative infinity? Well, you see this is not even a fraction. So in most of these problems, we're looking at a fraction, looking at the relative rate that the numerator and denominator are growing. But in this case, there's not even a fraction here. So this is n to a positive power. So the larger n gets, positive or negative, cube root will keep getting larger without bound, and squaring that will keep getting larger without bound. So this is really just going to go to negative infinity. It's not going to approach anything. The only way these things converge is if the piece that has an n in it is converging to a finite number, and often the expression with n in it is converging to 0. But that is not what's happening here. So this problem, in this problem, we'd say the improper integral diverges.